Good morning, students. Chapter 8, Electromagnetic Waves. Yes, Maxwell's equations show that there is something missing in Ampere's circuitous law, and it is called displacement current. And yes, this displacement current then leads towards generation of electromagnetic waves. Okay, now what about electromagnetic waves? Yes, varying electric field produces magnetic field. So if there are charges stationary and yes they are moving, okay, they produces electric field and magnetic field both. So yes, today we will see transverse nature of electromagnetic waves, or you can say Hertz experiment on electromagnetic waves. See, first of all, what is arrangement? Two metallic spheres connected with two metallic rods, and between them one spark gap S is produced. These two rods are then connected with induction coil, which provides high potential difference. So yes, it is construction. Easy to understand what is construction? Okay, again, two metallic spheres Q1 and Q2 are connected by means of metallic rods M and N, and the spark gap S is formed. Whenever this induction coil provides a high potential difference, spark is produced in this spark gap. Spark is produced, it means yes, charges moves across this gap. Charges moves across this gap. Okay? Yes. Q1 and Q2 constitute capacitor, while rods behaves as inductor. So yes, capacitor and inductor. So yes, we can consider, or we can say that this system is called LC circuit, or yes, it is also called from Hertz, it is Hertzian type. Clear? So it is construction, its explanation. Now what is working, how electromagnetic waves are generated? See carefully, okay, how electromagnetic waves are generated. See, here it is. Q1, I am assuming initially it is negatively charged, and this Q2 is positively charged. Clear about this? Q1 is negatively charged, Q2 is positively charged. So yes, in this region, due to these charges, electric field is produced. Due to stationary charges, yes, electric field is produced. I am taking one point here. Okay, so see, at this point, for example, what is direction of electric field? See, yes, you can consider this case as dipole, and due to dipole on its equator, what is equation of electric field? E is equal to, it is minus 1 upon 4 pi epsilon 0 P upon R cube. Minus means it is in opposite direction of dipole moment, or it is plus charge, it is minus charge. If you draw electric field lines, it will be like this. So on equator, what is direction of electric field? Yes, obviously at this point, direction of electric field, it is in direction of tangent, and it is in this direction. It is direction of electric field. Simple. So if I consider this point, then at this point it is direction of electric field. Clear about this? Yes or no? Again, if I draw, yes, it is electric field line. So yes, we know that at each and every point, electric field, it is in direction of tangent drawn at that point. Okay. So yes, it is direction of electric field. Now, due to this high potential difference from this spark gap, spark is produced. Spark is produced means as this sphere is negatively charged and it is positively charged. We know that negative charge can move due to high potential difference. So yes, electron will move from this Q1 sphere to Q2 sphere. Electron will jump this spark gap due to high potential difference. Yes, electron will move from Q1 to Q2. So yes, electron, it will move in this direction. Electron due to high potential difference provided by induction coil. So yes, we know that electron is moving in this direction. So conventional current, yes, conventional current, it is produced in opposite direction. It is direction of conventional current. Yes or no? Yes, please. It is direction of conventional current. Clear about this? Okay. Now, as electron is moving from this sphere towards this sphere, means charge is moving, means current is produced, and due to current Yes, we know that due to current magnetic field is produced. So yes, current is flowing in upward direction. Yes or no? We have to find magnetic field at this point. We have to find magnetic field at this point. So current is flowing in upward direction. Point is this side, so that finger towards this, thumb is inside. Yes or no? Thumb is inside. So at this point, yes, magnetic field is also produced, and that magnetic field is perpendicular inside. It is magnetic field. It is magnetic field. Clear about this? Okay? It means, see, here it is. At this point, if electric field is like this, then magnetic field is perpendicular inside. Magnetic field is perpendicular inside, like this. Okay? Magnetic field is perpendicular inside. Clear about this? Okay, so yes, due to this system, at this point, electric and magnetic fields are produced. Electric and magnetic fields are produced. Now, what happens? See, charge on this sphere gradually decreases. Yes or no? So its negative charge decreases and its positive charge, okay, it also decreases. What happens after some time? After some time, their polarity is reversed. Their polarity is reversed. If you know LC circuit, yes, in case of LC circuit, their polarity after some time changes. Okay, so now if this sphere becomes positive and this sphere becomes negative, second case, okay, second case, then yes, electron will now move from in this direction. Electron will now move in this direction. So conventional current is produced in this direction. So in this case, what about electric field and magnetic field? Suppose I am taking one point here. Then due to this, at this point, what happens? To see, as it is negative charge and it is positively charged, electric field will be in this direction. Yes, electric field will be in this direction. Current is in downward direction. So magnetic field produced here, it will be outside, perpendicular outside. Here it is magnetic field. Here it is magnetic field. Clear about this? Clear about this? Okay. Then again, what happens? So yes, again the polarity will again reverse. Polarity is again reversed. Then electric field at this certain point, electric field will be again in this direction. Okay, and magnetic field, yes, magnetic field will be perpendicular inside. Magnetic field will be perpendicular inside. Clear about this? To see, due to this system of capacitor and inductor, in this region, both fields are produced, electric field as well as magnetic field, Clear about this? Okay, how electric and magnetic field is produced? Due to these two spheres, electric field is produced, and due to motion of charges, current is produced. Due to that, magnetic field is produced. Clear about this? Okay, so what is conclusion? Yes, what is conclusion? See how to write conclusion. Thus, oscillating charges are responsible for the generation of periodically varying electric field and magnetic field. Periodically varying. Why periodically varying? Yes, varying, it means as distance changes, we know that electric field and magnetic field changes, so it is varying. Periodically varying means during some time interval, if electric field vectors, direction of electric field is in, for example, upward direction, then after some time it will be downward. Then after some time, upward, downward. For this magnetic field, right now it is perpendicular inside, then it will be perpendicular outside, then perpendicular inside, then perpendicular outside. That's why it is called. Thus, oscillating charges are responsible for the generation of periodically varying electric and magnetic field. This way, electromagnetic waves are generated. Clear? So, it is generation of electromagnetic waves in laboratory by Hertz experiment. Clear? Clear? Now, as these electromagnetic waves, it has some frequency. So, frequency of electromagnetic wave is equal to frequency of oscillating charges. Okay, yes, these charges are oscillating. It is initially negative, positive, then it will become positive, negative, then again it will become negative, positive. So yes, their polarity changes, okay, with some frequency. so that the same frequency is of electromagnetic waves produced. Okay, so frequency of wave is equal to frequency of oscillating charges. Okay, now how to change frequency? How to change frequency? Frequency we can change by varying distance between two spheres. By varying distance between two spheres. Clear? So if I change distance between two spheres, frequency changes. So frequency can be varied by varying distance between two spheres. What is relation? C is equal to H lambda. F, C is speed of electromagnetic waves, lambda is wavelength, and F, that is frequency. Clear? So yes, this experiment of ours was performed after numbers of years after Maxwell's equations. Okay, then after 7 years, Jagdish Chandra Bose generated electromagnetic waves having wavelength 5 mm to 25 mm. Yes, this one you have to remember. Okay, for MCQ. Then Italian scientist Marconi succeeded in transmission of electromagnetic waves. So yes, these 2 points you have to remember. See, what is Maxwell representation theory of displacement current, some equations. After that, Hertz experiment. After that, Jagdish Chandra Bose experiment. Then Marconi succeeded in transmission of electromagnetic waves. So conclusion is light is electromagnetic wave. Light is considered as electromagnetic wave. Clear about this? So yes, it is all about Hertz experiment. So yes, if you are asked the Hertz experiments, you have to explain this. Yes, the working you have to write. Working you have to write. Clear about this? Okay. Now some points you have to remember about electromagnetic waves. See, here it is. According to Maxwell's theory, yes, generation of electric field and magnetic field vectors are not instantaneous. Okay, yes, charges are oscillating, current is produced, so electric and magnetic fields are produced instantaneously. No. In the region closer to source, means oscillating charges, phase difference between electric and magnetic field is pi by 2. Means when electric field is maximum, magnetic field will be 0. When magnetic field is maximum, electric field will be 0. So phase difference between A and B is pi by 2, and magnitude decreases as 1 upon r cube. Magnitude means this magnitude of electric field vectors and magnetic field vectors decreases as 1 upon r cube. And such components are called inductive components. So yes, you have to remember what? Inductive components, magnitude is proportional to 1 upon r cube, and phase difference between A and B is pi by 2. Next one is, yes, at larger distance, electric and magnetic fields are in phase. Means phase difference 0. Means phase difference is 0. Okay, and magnitude varies as 1 upon r, and such components are called radial components. Such components are called radial components. So yes, you have to remember these 2 points. Okay, now next is, yes, electromagnetic waves. How to represent electromagnetic waves? See, here it is. When electromagnetic waves pass through any region in space, electric and magnetic field, they are perpendicular to each other, and also they are perpendicular to direction of propagation. Yes, see, for example, here it is source. Due to this source electric field, electromagnetic waves are produced. X direction, Y and Z. So see, here from this figure, electric field vectors, they are, electric field vectors, they are like this. Electric field vectors, they are like this. For first side, electric field vectors are in this direction. Then for next, it is in downward direction. Then it is upward, downward, and downward. While magnetic field vectors, they are like this. Okay, so if here, see carefully, if electric and magnetic field vectors, they are like this. See, it is electric field vector and it is magnetic field vector for first case, for first half cycle. For next half cycle, this electric field direction changes its direction. This magnetic field also changes its direction. Again, electric field up, magnetic field outside. Electric field down, magnetic field inside. So yes, A and B vectors, they are perpendicular to each other, as well as they are perpendicular to direction of propagation. So yes, this point we have to remember, because yes, Due to this transverse, yes, it is called transverse nature. You know transverse waves and longitudinal waves. Yes, you know transverse waves and longitudinal waves. So yes, it is called transverse nature of electromagnetic waves. It is called transverse nature of electromagnetic waves. Clear about this? So yes, it is very easy theory about this. You have to remember this picture. Okay, about electromagnetic waves. The electric and magnetic field, they are perpendicular to each other. They are also perpendicular to this direction of propagation. Now, what about energy of electromagnetic waves? Energy of electromagnetic wave is equal to kinetic energy of oscillating charges. Okay, so yes, it's all about electromagnetic waves. Now, in next lecture, we will see some characteristics regarding electromagnetic waves, and it is one important topic, one important question of this chapter. Okay, this is it for today.